Hello. This is a demonstration of calculating a mean standard deviation from a frequency table in the MEI S1 syllabus. I'm using June 2010, question 5. Most important thing to remember in the world of MEI is that in MEI, standard deviation is square root of the sum of the squares divided by n minus 1. That just moved there. That's the most critical thing, is their definition, and that's the one we got to use. Okay, I'm going to take us through doing it two ways on this one. Firstly, I'm going to do it the long way manually, just so we know the quickest way to create a table. Secondly, I'm going to use calculator and do it more quickly. So we've got two ways of doing it. Right, let's have a quick read as ever of the question. A retail analyst records the number of loaves of bread of a particular type bought by a sample of shoppers, which is why we should really be using n-1 as it's a sample. And here's the data below. There we go. So we've got the number of loaves in the top row here, and we've got the frequency there. Part 1, calculate the mean and standard deviation of these numbers of loaves bought by a person. 5 marks for this. Okay, well, let's get to work. I'm just going to create a table and populate it as quickly as I can. So there's our data from above. I've just made it into columns rather than rows so we can do the calculations. So X is our value of loaves, that's our loaves, and that's the frequency, that's the number of occasions, isn't it? Okay, what's the first thing we want to do then? We want to calculate XFX in order to find our mean, so that's going to be our next column. So the first one's going to be 0, 0 times 37, 1 times 23 is 23, 2 times 11 is 22, 3 times 3 is 9, 4 times 0 is 0, and 5 times 1 is 5, and if we add that lot up, we're going to get 59. Excuse me, I just want to get a little bit more space so we can see. How much of the size of the sample? That's the frequency total, that's 75. Okay, so what's our mean going to be? Our mean is going to be our XFX divided by our number. So that's our 59 divided by 75. Going to give you 7.787. I've rounded that there. Keep to 3 significant figures of decimal places for MEI. So that was fairly straightforward. What's the second step we need to do? Well, we now need to go on and find the standard deviation. For that, we need the sum of the squares of the differences. So quickest way to do this on table form is to calculate x squared of fx. 0, 23, 44, just multiplying out what we had in the columns before, 27, 4 times 0 is 0, and 5 times 5 is 25. That lot adds up to 119. There we go. So now we've got our data. Now what formula are we going to use then to find our standard deviation? Well, we're going to use the standard deviation is the square root of the sum of the squares divided by n-1. Sum of the squares here, well, we've got the sum of the x squareds, that's 119, so that's our sum of x squared fx, but we've got to correct, so that hasn't been corrected yet for the mean. So we've got two ways of doing it. We can either take our mean squared and multiply it by the number, because that's how many the sum of the squares of that lot would be. The other way of doing it would be just to take our fx figure and use that. So I'm going to do it this way quickly. So I've got my sum of the squares is going to be 119 minus the x bar we worked out was 0.787 squared times 75, and that's going to give us a total of 72.59. Okay, let's just have a quick look down. There is one other way, a slightly different formula. Let's do it in a different color so we can see it. Slightly different formula, which is where we use the x squared f. The first term's the same, but in the second term we have our sum of the x times frequency, and we square that, and then we divide that by n. You'll see that effectively these two terms are the same. It's just a different way rather than calculating our mean. So again, we'd have 119 and we'd have 59 squared, and then we divide by 75. These two numbers are the same, and we come back to the 72.59 for our sum of squares. So that's going to x. So what's our standard deviation? Standard deviation s, that's little s, sorry, it's not clear, let me just write it so it's really obviously a little s. Here 72.59, and we're going to divide it by n minus 1, that's 75 minus 1, and that calculates out to 0.990. I'm going to leave the 0 there because I want to work to 3SF again all the way through my answering. So that was pretty straightforward, and it took us a few minutes to do that the long way and with an explanation. Okay, so let's do it using calculator. Any of you who've got any sense will get a calculator because it'll avoid you making any number errors. We get to our menu stats, and we'll get our table up and we're going to put our lists in. The first list is going to be our data, so that's going to be 0, sorry, it's going to be 0, 1, 2, 3, 4, 5. So that's the first column. In our second column, we're going to put our frequency, 37, 23, 11, 3, 0, and 1. There we go. So there's our items. Now we're going to go and do the calculation. Click calc. Now the only thing we need to make sure, which is people get wrong in exams, you must make sure you've got your setup right. So click on the set. And let's see the first. Here we can see our first, the X list for one variable is set as list 1. The one variable frequency, well, we've put that data in the second table, so second column rather, that's called list 2. So we're going to change that to list 2. There we go. So it now knows our calculator what we're going to do, and we're going to use that information. We're going to use that setup. So now we know we've got a single variable here. We've got its variable and frequency. So we're going to click one variable, and hey presto, here's our answer. Came up. So here it's told us that our first line here, that our x bar is 0.7866 recurring, and we've rounded that to 787. And on this calculator, it's written as x sigma n minus 1 on this simulator. On your calculator, it might just say s of x, and that's come up as 0.990. At least on this format, you can see which is n and which is n minus 1, and there's our n of 75. So that would have been much quicker as long as you get your setup right. So do check your setup. Okay, on this question, they've got a part 2 for 3 marks. Each loaf costs £1 4 pence. Calculate the mean and standard deviation of the amount spent. So in the first question and in the data table, we have the number of loaves. We've now got to convert that into cost. So this is basically a linear coding question, isn't it? Linear coding. Each loaf. How much was it? £1. Excuse me, I just have to go back and check. £1 4 pence, isn't it? Yeah, £1 4 pence. Okay, so what's that do to the mean and standard deviation? Well, we'll know from our work on this that the mean's just going to be scaled. So that's our 1.04 times What do we have? 0.787 gives us 0.818 or 81.8p, and the standard deviation, again, we're only in a scaling, we haven't got a shift here, have we? If there was any shift along, it would make no difference. We've only got a scalar, no difference to standard deviation. So here we've got a 1.04 times our standard deviation before, which was 0.990, and that gives us a figure of 1.03 or 103 pence as being our standard deviation. So here we weren't shifting, remember, so we're just doing a multiplier on our scaling for our linear coding. So that was very easy, wasn't it, for 3 points? Okay, as ever, here's my quick summary. For mean standard deviations delivered to you by me on a frequency table, I do recommend you use a calculator. Load the data in and do the calc that way, but do check the setup is correct. That's the biggest mistake I think that people make. Or if you haven't got a calculator, create a frequency table as I've done above, and then make sure that you divide by n-1 to calculate the standard deviation, not by n. And if you're on the calculator, make sure you pick the s, not the x. Yeah, from the calculator it's s, sorry, not the sigma. That's the one you want. Okay, so I hope that's of use to you, and best of luck.